Okay, so to demonstrate the action system, we're going to make a teleporter. So to start this, I'm going to go to my developers folder, which is useful for testing out stuff, and make a new blueprint. And this will be our teleporter. I'm going to base this on the grid actor blueprint, which is a blueprint included with the toolkit, because this has a few handy functions such as snapping to the grid and finding automatically the grid index of the tile it is placed on. So I'm going to use this as the base, and let us call it BP for blueprint teleporter. There. Okay. First, let's decide how our teleporter is gonna look. So we can simply add a static mesh, and we can call that static mesh teleporter, and then we can choose something that will look okay, something like maybe hexagonal tile. And now if it looks like this, it will just overlap perfectly with the tile it is placed on. So let's first resize it a bit, and let's attach this mesh to the grid anchor so that it works with grid snapping functionality, and then we should take it up a tiny bit. I think 37 is the height of the regular tiles, so that should place it on top. Let's see if that works. Let's place it in the grid, see if that works. So grid snapping, yeah, it's almost working. Now the reason for this jumping happening is because it is this tile is or the ray tracing for the ground that is used to determine where the tile should be placed is actually colliding with the mesh itself. So we have to turn off path trace collision for this. So let's see, under collision we can put this to custom and ignore path trace, and then it does not collide with itself, and yeah, now snapping is okay. And it is actually hovering a bit. Yeah, of course, because it is resized, we have to take this, let's see, there we are. Just take 60% and now it should be flush. Yeah, great. So that is working well. Still looks a bit bland though, so let's change this to, let's see, red. Yeah, red transparent. Yeah, that looks sufficiently as a teleporter. Okay, so we have the look of this thing. Let's start adding some functionality. We're not gonna need ticks or overlaps for this one, so let's get rid of that. But an event begin play node, we can use this to set up some references, which we're going to use later. And we are going to need some way for this teleporter to understand that it has been stepped upon, so that we can then teleport a unit. And how are we to do that? Well, we have some useful stuff in the grid manager. And thankfully, since this is a grid actor, we already have access to the grid manager ref. So I'll just control drag a reference out here. And what we can use is an event dispatcher that is in the grid manager, which is called on unit enter, let's see, on unit end movement simulate. This one is useful. I can show where this is in the grid manager, by the way. So actually it's called initially through the unit blueprint. Let's see. So during, let's see, I was already in the correct place. During this simulate move function that we talked about in the last video, once movement is done, so all of this is the movement simulation, then this this event dispatcher, which is contained in the grid manager, is called, and this is the on unit end movement simulate event dispatcher. So this, so if you don't know what an event dispatcher is, it is something that sends out sort of a call that something has happened, and then you can set up other blueprints to listen for for that event dispatcher. And then you can have events on all different blueprints that are listening for that particular event to fire at the same time. And at least if we have don't have teleporters on every other tile, that's a reasonable way to set this up. So as you can see, this event dispatcher is called, and it has input, which is the grid index which the unit now occupies. Since this is called at the end of movement, this will be the grid index at where the unit ends up. And it's also a reference to a unit, a reference to itself, and this is called from the grid manager. And why this event dispatcher is called from the grid manager and not an event dispatcher that is on the unit itself is because there's only one grid manager. So if we tie other blueprints to this event, this dispatcher in the grid manager, it always knows which one to listen to, while for units you would have to have a separate one for each, which would make it more complicated. So anyway, this event dispatcher is called at the end of movement. So if we go back to the teleporter, then if we actually, we shouldn't call this, but instead, let's see, we bind an event to the on unit and movement simulate. So this means that we are going to bind this event, so when this event dispatcher fires, we are going to fire this event. So we make a new custom event and we call it teleport. There. So now whenever any unit ends movement anywhere, this event is called. So of course we don't want to teleport a unit whenever that happens. We only want to do that when they happen to end on the very tile that this teleporter is occupying. So what do? Well, we can simply then just check this is the grid index of this teleporter. Since again it is of the grid actor type, we have access to its grid index easily. If we did not have access, you could use the grid manager to convert a location to a grid index, but we don't need to do that here. So we check if they are equal, and I click B to create a branch, by the way, and if they are, then we want to teleport the unit. Okay, great, but where do we teleport to? So we're gonna need a reference to another teleporter in some way, and let's just do that in the simplest way possible. Let's add a new variable. We can call it paired teleporter ref, and we also make this of type then BP teleporter, and we can create a reference for this, and let's just set it up so we can define this reference directly in the viewport, so we make it editable like so. To tie this up to the action system, you'll note that this is named simulate, and you saw that it was called from this movement simulate function in the unit blueprint. So this is something that happens server side, and it happens over like a single tick, and it is not shown to the player. And that's important because we are going to do stuff now which affects the grid manager and affects like important gameplay stuff, and not just things that we are showing, not just stuff that we're showing to the player. So since we are now server side and simulating, we are going to move this unit, the unit that ended up here, from the teleporter to the second teleporter. So for that we are going to use some functions from the grid manager. So we can then, let's see, remove unit from the grid, which is a function just for this sort of thing. See? Yeah, this might actually work better as a function, but yeah, I can clean it up later. So yeah, we remove the unit from the grid, and then afterwards we want to add it back onto the index of the other teleporter. So we can get another reference and we can add unit to grid instead there. Okay, so yeah, this would be better. as a function. But yeah, let's make it a bit more quick and dirty. I can't help but tidying up a bit though. Okay, so how do we get the grid index? Well, we have this paired teleporter reference, so we can just get the grid index from this teleporter, and it should work fine just like that. Let's actually place a second teleporter in our map so we can test this out as we go. So, yeah. Now we got 2 teleporters. That's a nice close distance. And this is teleporter 1, so we set the paired teleporter to be teleporter 2 and vice versa. Let's see, yeah, like this, and let's see what happens. So if we move here, nothing happens, but something should happen. Let's see. I used unbind instead of bind. I've done that so many times now. We are instead going to use the bind event on unit end movement simulate, but it should work exactly the same there and there. And let's try again. What happens this time? If we move, there's no teleportation, but as you can see, visibility is around this teleporter. So the unit has moved in a sense. The reference to the unit is now on a different tile, but the unit is still standing here, it seems. And if we are the other units, you can see that we can move onto this unit, but we can't move onto here, and that's because when pathfinding is checked, which is done like in the grid manager server side, then it looks only at the unit array for which there's a reference to this unit, but for the animation the unit is still standing here. So therefore we are going to have to use an action. So let's go back to the teleporter. So it's time to queue an action. So after adding this unit back to the grid, then we run the queue action macro. So what do we need to input here? Well, we need to input where this animation is going to happen, and if we have no reason for doing it otherwise, we might as well do it on this teleporter. So let's set the executing object to self, and we should name the action something. So let's just call it teleport, and it should not be immediate. If it were so, then when we clicked to move to the teleporter, we would instantly kind of teleport to the other one before movement had really even started, and it would look all kinds of weird. So we do not want it to be immediate. We could maybe have it to instantly deactivate if this teleportation is instant, but I think I'll add a little bit of delay, so I will not use that. We're fine with it being at the very end. We don't need to have this happening earlier than other actions we have previously queued, so we just leave this at -1, which means that it is at the end. We don't want it to be with the previous. We're fine with this happening after movement has ended, and we don't need an activation delay. We could do that, but if we want some delay stuff, we can just also add it directly into the animate action event, which gives us more control over where we want to have the delays. So what do we need to input in this case? Well, we need to input the unit that we're moving, and we need to input the location of where it is going. So let's input one unit, but this is an array, of course, but we do not need to add several units. So we can just use this, make an array of 1, and we can input the very same unit we're using here. And as for the vector, we are going to need to find the location of this paired teleporter, and we can do that quite easily by just let's see, getting the actor location. There we are. And we can just really input this directly into vectors. So now we have really the 2 values that we need. Okay, so now we need to add the actual action. We need to add the animate action event, but we don't have that as yet, just as we can send it as a message to a different place, but we need this as an event in this blueprint. So we need to add the interface. So we go to class settings, we add an interface, we go to BPI action, and once we've done that, I'm compulsively compiling, as you see, bad habits, then we can add the event animate action. Okay, so this is then the event that is called from the action manager when it is time to run this action. And here we're going to do all the stuff that we're actually seeing in the game. So the first thing we want to do when this event is called is to break this action struct so we can get access to the variables in here. We first make then a switch on name so we can do different things depending on the type of action that is called. Now, I mean, this might be the only action that is ever called on this blueprint, which means that this switch might be unnecessary, but I think it's good to do it just to have more control anyway. So we don't need a default pin in that case, and we add one that we call teleport. So since we use the teleport name here, it's case sensitive, then it checks when it goes here, okay, this action is called teleport, we want to do this thing. And what do we want to do? Well, we want to move the actor to the new position. So we need to get access to the unit, which we input here, which is of course at index 0, so we just get a copy of that one, and we need to get the location, so we can also get the location of that we input. And let's make it a bit prettier there. Okay, and then we can simply set actor location, and we can get this location value that we have here. And as a last thing, since we did not choose instant deactivate, which we could in this case because it is instant at the moment, but we should get the game state and then call the end action message. And that should be enough to get some basic teleportation set up. Let's see how it looks now. So we have the same teleporters. If we move to this one now, yeah, I teleport, but he's strangely offset and clipping through. Of course he is. Now the thing is, we are getting the actor location of these meshes, and actually the actor is, as you see, placed on are not centered at all. It's the meshes that are centered. We could use the place actor at anchor let's see, boolean here, which if you click it automatically centers it, but we don't want to need to have to do that every time for our teleporter to make sure that it looks okay. So let's just keep it weird and change it up so that it works. So then we want to get the center of the tile and not really the location of the actor. So to do that, let's get the grid manager reference again, and let's get the grid locations, which is a map that contains contains the locations of each grid index. So we find, in previous versions this used to be an array, now it's a map. We find the location corresponding to the grid index of this paired teleporter, and we input that instead of getting the actual location itself. And if we try now, let's see what happens. Okay, it's centered, but he's still down in the ground, and there's a reason for that. That's because these units, they are characters and they have a capsule component. So the center of that component is actually here in the middle. So if you place it down on the floor, then it will clip through the floor. So we're also gonna need, from the unit itself, let's see, capsule, oops, there, okay, so we can get the scaled capsule half height, there. Okay, now it's getting really ugly. Let's tidy it up a tiny bit. There, there. And we need to add this to this location. So let's break or split both of these, I mean. We're adding this to the height, like so. Okay, now let's see if it works. If not, I'm gonna be surprised. There we are. Okay, beautiful. Though this teleportation, it looks a bit tame, and I think there's another issue as well. If I now move with this guy here, yeah, he teleports as well, and they overlap, and this is going to cause all sorts of issues. So let's address both of these things. Let's address this thing first, actually. Should be easy enough to fix. Just have to check here. So the then grid index of the paired teleporter, it needs to be unoccupied. So let's also get then this grid index. Let's move all of this just a bit so we have some space. And again, get the grid manager reference. And then we can get the grid units, which says which unit are on what grid indexes. So then we can find this particular grid index of the teleporter we are teleporting to, and we can then check. Actually, we don't even need find. We can check. We can have contains, because it is a map, so it really only has the indices of where there are actually units occupying this grid, which is the benefit over using arrays as I did previously. So we add a new branch using B, and if it contains, then we do not want to teleport. If it does not contain, then we do want to teleport. Yeah, maybe I shouldn't be this obsessive about this stuff when I'm making a tutorial. Yeah, okay. So now it should not be possible to then teleport when there is another guy occupying the other one. So let's just try that out. Now I'm here. Now if I go here, I do not teleport. Wonderful. Okay. So now it actually works just as it should. It's just not very flashy, so we can improve how it looks. But before that, I'll just reiterate some of this stuff to make sure that I've explained the important thing to get here. That this stuff is done like server side. It is called then from this simulate event and all the stuff that's on the server. And this stuff, it cares about really the grid and these grid arrays and so on. Everything kind of works in grid space, and it does not really care where the actors are actually placed in the world or something. It just cares really about these, abstract arrays in the grid manager and various blueprints. So you can have the entire gameplay through this stuff and really never have this stuff happen, and it would be identical. You just wouldn't be able to see any of it, of course. This is also a benefit of this, is that you can now more easily kind of change the entire look of the game, since you still have all the basic gameplay stuff working in the background. And if you change this, you can make you're even freer in designing how your game actually looks and behaves. So this stuff then in the animate action part here, we don't want to mess around really with the grid manager and the arrays and so on. Here we're going for all the stuff that the player actually sees. So we're going for locations, we're going for actual actors, we're going for all of that sort of stuff. So that's really the key difference between these two things. And if you follow that, then you have the benefit of it working for network multiplayer, of course, but also other benefits, because before the way you would do this when the two things are tied together, both the animation and like the underlying processing, then when moving a unit, you would have to then wait until the unit has moved all the way to the end, and then you would fire like an event dispatcher or a custom event or something to let the grid manager know that the movement is done, and then you can continue with the next part of like calculating a shot if it's the AI, for instance, or something like that. And that becomes a bit cumbersome with all of these back and forth events and references and all of this stuff. Now, when you have this action system, you can just send all of the actions to the action system, and it takes care of actually setting them up one after another. So if you manage to work with this, it actually becomes a lot easier, and you get also cleaner blueprints this way. And a note aside, I'll get to printing this up. This is how it is, or similar to this, is done in a lot of turn-based strategy game. You might have noticed this if you say you play Hearthstone. In that game, when you play a card with a complicated effect that has a long animation, then you will see that if you that card ends up killing your opponent, say at the end of the animation, you are immediately not able to click the end turn button. It goes from like green to yellow to indicate you can't click it. So the game knows immediately that your opponent is dead, but you don't know it really until all the animations have shown. You can see a similar thing in XCOM, where when it's the AI's turn, you sometimes get an achievement and you don't realize why until the AI runs up to your guys and you Overwatch shoot them down, and then you get an achievement for killing that particular enemy. But you got the achievement immediately at the start of the AI turn. So this is also an example that, this is done generally in turn-based strategy games. Okay, so now let's make it pretty. So everything that we do to make this look pretty, of course, you should be able to guess this by now, that should be done down here, never up here. So we don't need to be too fancy, but let's have something more than just, simply moving it. So particle effects are always nice, so let's before setting the actor location, we can let's see, we can spawn an emitter at a location. Let's move this a bit, and we can use, let's see what we have. Let's use the explosion, that's at least flashy, and we get the location. Now wait, we want this to be the location where we start. So let's get the location of this actor before it is moved as the location for the explosion, and let's increase the scale a bit because I know this effect is pretty small. Okay, and then we set it to a new place. So you could also, of course, add a function and so on to this part. When you add a function, you can use the inputs as local variables, and you don't need to have all of these like cables going all over the place. But just look into any of my other functions to see how to do that. That's a very useful way to organize blueprints. But okay, now we should have an explosion. Let's see how it looks. Boom. Yeah, that looks a bit more like it. And maybe we should have like it so it feels a bit more like it takes some time. So we have the explosion, and then it takes a bit of time, and then it shows up at the other location. So if we do that, let's see, we can second, this should work. Set actor hidden in game. There it is. Set that to true. And then we add a small delay. I don't know what's gonna feel good, but it should be fairly short, maybe something like 0.3 seconds. And we set the actor location. Oh, new subscriber. Hello, Eric. Hope you enjoy this video if you see it. Okay, let's see. Moving here. Oh yeah, we're still of course invisible. So we need to again then undo this. There. And let's see. What? Oh, got way too distracted by getting new subscribers. I need to close this. So, there we are. Okay. Maybe make it even a little bit more flashy. We can add a new like emitter. Now I'm just not gonna bother making it pretty at all just to get this stuff done. Let's see, spawn emitter at location. Exactly, we can still use the actual location, that's fine. And everything, we don't need anything else than that. There we are. Okay, so now we got a nice little teleporter effect. Yeah, and it should work multiple times. Yeah, the AI is going now, so I don't need to show that, but it works at least, yeah, both ways. And you could add any number of these teleporters into your game, but yeah. So the main point wasn't showing how to make a teleporter, though of course that might be useful too. Worth noting is that the AI would not know how to use this thing at all, so if you keep it like this and really want to add something like this to your game, either set it up so that only player controlled units can use it, or you will need to go a bit more into AI. And when it comes to turn-based strategy, AI is always the most difficult part. But if you want to make something like this that's actually a bit more advanced, just go to me in the support thread and I'll try to help you out there. Okay, I hope you learned something about my action system. I hope that you also feel that it is useful and improves the toolkit, and that it's not too confusing to work with. And yeah, again, if you're confused, let me know in the support thread or the YouTube comments or anywhere. I generally prefer the support thread on the Unreal Engine forums, which is linked to in the description of every one of my videos, because I can give longer answers, and I can include images and pictures of blueprints and so on. So, but if you have a quick, easy to answer question, then by all means post it on YouTube. That's fine as well. So, yeah, that'll be that for the action system. And yeah, I'll see you in another video.